confirmed. The host has placed the meeting in.
Welcome everyone to the Investigating Earth with Astronaut Imagery from Space webinar. We are coming to you from the NASA Johnson Space Center in Houston, Texas. And we're so glad to have so many groups on the line. We've got Freeland-Heisen Middle School from New Jersey, and we've got a couple of groups on the line from there. Green Park Lutheran School in Missouri, Mauburn Academy in Ohio, Murfreesboro Middle School from Illinois, Pine Lane Elementary from Colorado, and we may have a couple of other groups joining us as well. So we're kind of here in sort of warm Houston, Texas, and for those of you in other parts of the country, we hope you're staying warm as well, but we're really glad that you're joining us today. As we get started, just to let you know a little bit of what we're going to be covering, my name is Paige Valderrama-Graff, and I'm going to be introducing myself as well as our other speaker will introduce herself in our general introductions that will start here in just a moment. Then we're going to get into the large portion of our presentation today, which is about exploring Earth using astronaut imagery from space. And we're going to share with you awesome images covering 4 different topics that we hope you'll find exciting and interesting, because you may, in the end, want to think about requesting new astronaut imagery, and we'll talk about that. And then we'll have a question and answer session for you guys to ask us questions about what you're curious about. So a little bit about us. First of all, my name is Paige Valderrama-Graff. I'm on the right here. I am actually originally from Staten Island, New York. I went to school at Indiana University for one or a couple of degrees, and I've also gotten a degree from Penn State University in Earth Science Education. I am a former classroom teacher, but I've been working with NASA since about 2001, and one of the best parts of my job is working with scientists like Melissa Higgins and being able to bring the science that they do on a daily basis to students and teachers across the nation. So that's a little bit about me. Melissa, why don't you introduce yourself?
Hi, everybody. My name is Melissa Higgins. I have a degree in meteorology from the University of Oklahoma, and I joined the Earth Science team here at NASA Johnson Space Center about 4 years ago. So I get to do really cool stuff with astronauts on a daily basis, and I'll talk to you about that in a second.
And Melissa is here in the right-hand side in the green shirt with a couple of other folks who happen to be on a conference and speaker sort of visit to Europe. That was a fun trip. All right, so as we go on, we want to first give you an introduction to observing Earth from space, because every image that you're going to be looking at today is coming from the International Space Station. So let's give you a little preview about the International Space Station.
A giant among Earth satellites, presented by Science at NASA. The International Space Station has been called a stepping stone to other worlds. NASA hasn't forgotten, however, that the behemoth space station is also the doorstep of Earth. We're seeing the space station come into its own as an Earth observing platform, says Julie Robinson, Chief Scientist for the International Space Station program. It has a different orbit than other Earth observing satellites. It's closer to Earth, and it sees Earth at different times of day with a different schedule. In short, the space station offers something unique to the study of our home planet. Sometimes astronauts in low Earth orbit can see what regular satellites do not. In May 2013, for example, astronauts on board the International Space Station photographed a fresh eruption of the Pavlov volcano in the Aleutian Islands. Their oblique perspective revealed the 3-dimensional structure of the ash plume, which was only 20,000 feet high, but many times longer. Down-looking satellites could not get the same kind of 3D information. Low Earth orbit turns out to be a great place to study the planet below. In recent years, astronauts trained to photograph Earth have gathered data on desert dust, coral reefs, urban growth, pollution, glaciers, hurricanes, lightning, river deltas, volcanic plumes, northern and southern lights, and much more.
So that gives you a little bit of a sense of the International Space Station, these astronauts that are on board, and the fact that they are able to take imagery from space
now, however,
is a really exciting thing. So as we go through our presentation today, we're going to hear from Melissa about how she actually works with the astronauts to train them.
So on a daily basis, we get to talk to the astronauts and have them take pictures for us from the ISS. So not only do we get to do that, but we also get to train these astronauts on different Earth science topics. For example, we'll train them on geology, on volcanology, we'll train them on oceanography, and several different Earth science topics, so they get a broad overview of what they can expect to see and what their photography is going to do for us from space. We also get to communicate with the astronauts, like I mentioned, daily to request images to be taken of Earth targets. So here on the right, you can see astronaut Dan Burbank with a bunch of different cameras that he's holding up in space, kind of being silly, but you can see the different cameras that we have up there that the astronauts can use. We also get to work with classrooms and scientists from all around the world to help them get imagery taken for their project from space. Here's an image here for Evergreen Middle School, and we took an image of the Viedma Glacier down in Patagonia in southern South America, and we gave that image for them to do different science experiments with or whatever they need to do it for, but we get to do that for scientists in classrooms all over the place, and Paige will talk about that later. The last thing is we also get to aid in disaster response, so we can see an image here on the right of really heavy fire smoke over in Australia. And one of the things that we can do with this imagery is to help give more of an aerial perspective to see just how much area has been affected by these storms or fires or whatever the case is, so they can send aid to those areas that need it the most.
So that's a little bit about what Melissa does on a daily basis, and the imagery that we have that's been taken by these astronauts during this presentation, we really want you to be thinking about what could your class perhaps investigate about Earth using astronaut imagery from space. So sort of keep that in the back of your mind, because that is a real reality, as Melissa just mentioned, and we'll talk about more here in a moment. So as we get started, let's see what kinds of thoughts you guys have as Melissa asks this very first question for us.
We're going to first focus on hurricanes, and so in the chat window, if you guys can answer this question for us, describe or name some features that you might expect to see in astronaut imagery of hurricanes taken from space.
So let us know in the chat window, what do you think you'd see? What kinds of features? And again, make sure your chat window is set to send to everyone. So let's see what we get. We'll stand by. All right, so at least we know Green Park Lutheran School can hear us, and they are mentioning we could see spiral clouds as well as the eye. Freeland-Hoyson Middle School from New Jersey also says spirals and eye in the eye of the hurricane. Swirling motion from Marburn. Pine Lane Elementary is talking about the eye. I'm so glad everyone kind of has an aspect of there's an eye of these hurricanes and swirling clouds around the eye. Well, let's see what this really looks like, because these were great answers.
Absolutely. This kind of gives you an idea of what the astronauts can see from space. So we can actually see the extent of a hurricane just looking from their window up at the International Space Station. And we can see everything from a broad perspective, so the entire storm as it approaches land, or we can see very detailed features of the hurricane itself. So first, if we want to take a look at the broad perspective, this is if the crew member has a very short lens on their camera, which allows them to see a very broad area, kind of like what you see here. So we can see storm bands, which the spiraling clouds, as everyone mentioned before. We can see the rotation of the storm itself. We can also see features like the eye wall of the hurricane, the eye of a hurricane, which many of you mentioned, which was really great. Another thing that we can see in these broad perspectives is the turbulence of these clouds. So you can see the bumpiness, very fine bumpiness around, especially the eye of the hurricane here, but we can tell those things from these images. Now, if the crew were to switch their camera lens to a longer lens, we can see more details in the storm itself. So right now, we're looking at the eye of a hurricane and the eye wall surrounding it. This is where the most turbulence is happening in a hurricane. So you have the strongest winds here, the most lightning, very chaotic circumstances are happening all around this eye wall here. But in the middle of the hurricane itself is actually much different. It's very calm and quiet. Now the thing about this, if I were to stand in the middle of the hurricane eye and I look straight up at the sky, depending on the strength and the magnitude of this storm, I may actually be able to see blue skies, which is also, very different from just the hurricane itself, as you can see very heavy clouds around it. But the eye itself of a hurricane is pretty clear. We can also zoom in a little bit further to this picture and we can see the turbulence here surrounding it. But we can also see, from space, we can see the ground from this eye. So we can kind of make out the blue water underneath this hurricane here just by the very blue tint that we see. And scientists really use this sort of imagery to understand what's happening in the eye wall of the hurricane a little bit better, because it's where you find a lot of information about the hurricane itself, is all in this area here. Not only can we see them during the day, but we can actually see them at nighttime, which is kind of strange if you think about it. If you're sitting at home and it's nighttime and a storm is rolling by, you don't really get to see the way that the clouds are moving very well. But the way that the moonlight reflects off of these clouds, astronauts can actually see in great detail these storms from space at nighttime. So we can see, as you all mentioned before, the spiraling clouds around the hurricane itself. We can see the turbulence in these clouds. But one neat feature that you can only see at nighttime is the lightning happening near the eye wall of the hurricane. And if we go forward one more slide, we can actually see that the astronauts were looking straight down at the hurricane eye. So we can see a little bit of the blue water of the Indian Ocean here in the eye itself, because this lightning here is illuminating the water underneath it. And we can also make out some more turbulence around here. So we have another question for you guys. Do you know what the difference is, if there are any differences at all, between a hurricane and a cyclone?
So think about that. There's two pictures there for reference, and then we'll have you put your answers in the chat window, and we'll wait to see what kind of answers come in. All right, so from Pine Lane Elementary, we're seeing cyclones have more turbulence. Hurricanes start in oceans and cyclones don't. Frelinghuysen Middle School is saying something about the wind speed or part of the world it's in. The other Frelinghuysen Middle School group perhaps is saying that the rotation of the storm is different. Green Park Lutheran is talking about cyclones happen over water, so maybe something about this location is coming up in a number of the answers. Marburn Academy is saying maybe a hurricane is at day and cyclones are at night, so perhaps it's something to do with the time of day. So Melissa, this is a tough question and one that comes up often. What is the difference between a hurricane and a cyclone?
Well, we actually had it right in a couple of the answers here that the rotation has a huge part in the difference between these two storms. Now, they're both known as tropical cyclones, but a hurricane forms in the northern hemisphere, so usually in the northern Atlantic Ocean or over the far, far eastern Pacific Ocean, so near California area, the hurricane will form. And what the difference is here is that we can see that the rotation moves in a counterclockwise fashion whenever it's a hurricane. Now, if we move over to a cyclone, those happen in the southern hemisphere. So we can see that there's actually a clockwise rotation here. And those happen in the southern hemisphere. Cyclones specifically form usually over the Indian Ocean area or the southern Pacific, maybe near Australia. So those form in that part of the world. There's also something known as a typhoon, which will form in the northern hemisphere, but in the very western Pacific, like near Japan and China, in that area.
So great observations that you guys made, and thanks, Melissa, for the clarification, because these are terms that oftentimes do come up and that can be difficult to sort of keep track of.
Absolutely. So not only can we see these broad-scale storms from space, but we can also do a little bit of research on how an area was affected before and after a storm hit the area. So right now we're looking at New Orleans from space, And we're looking at it a couple of years before a very large hurricane hit this area. That hurricane was called Hurricane Katrina. I believe it was a Category 5 as it hit, which is the strongest category a storm can be when it hits an area. So if we look at here, this is a couple years before Katrina, and this is just a few days after Hurricane Katrina hit. Now, it's hard to see what the difference is between the two, so let's do a side-by-side comparison. Here are those two images again. So if you see over here on the right-hand side, this is post-Katrina. We can see that it's darker in this area here. The roads are a little bit darker. And in this area over here, we've got a neighborhood in this area that looks darker than this area here. And we also have a city park in this area, but you can see that there's a large difference between 2 years before and a couple days after the storm hit. Here's what happened. This is the downtown New Orleans area here. So on this side here, this is what it looked like before and after the Katrina hit. So you can see that there was this massive flood that came through the streets of downtown New Orleans. Also, there was a levee that burst right up here in the upper right-hand corner of this image. And what happened is this entire neighborhood over here on the left went completely underwater from that levee bursting, and the city park was completely submerged in water from this hurricane hitting. So it did a lot of damage in this area, and you've probably heard about it before, but just the pictures from space that we can take and do research is astounding.
All right, so we're going from hurricanes and the floods that a hurricane could bring in to now switching gears to talk about another dynamic event, which are volcanoes. So in the chat window, again, before we show you any pictures of volcanoes, what features do you think you might see in astronaut imagery of a volcano? So go ahead and put your answers in the chat window, and we'll see what type of features you think might be visible. All right, so we're getting from Freeland-Heisen Middle School, dark clouds, ash, lava. Pine Lane Elementary also agrees, ash, as well as raised black terrain or lava and the mountain or the structure itself. Perhaps some of the rocks associated with the volcanoes. Mauburn Academy is also saying lava, as well as perhaps even glowing clouds or ash. That's an interesting thought there. And Green Park Lutheran is saying the mountains or structure itself, black rock, smoke, ash, clouds, even obsidian, which is a volcanic type of rock, as well as smoke from Freeland-Heisen Middle School. So good thoughts. Let's see what these things actually do look like in imagery from space. So as many of you have said, you can see the volcanic structure in itself, which is seen in this picture of Sarachev Volcano, which is near Japan. Now, this image is actually showing an actual eruption as it is viewed from space. So you see the volcanic structure, you see the ash and smoke that is coming out from this very explosive eruption that's going on here. What's really interesting and what you wouldn't get from a ground view is this billowing cloud of ash and gas that's coming out from this volcano. So keep in mind that different types of volcanoes have different types of eruptions, and the eruptive materials might look different. So let's look at another volcano. Now, we saw this one in the video you saw in the beginning of this session. This is Pavlov Volcano, which is part of the Aleutian Islands, which is off the coast of Alaska. Now, this volcanic eruption you can see here, you can really get a view of how different these eruptive materials are coming out of this volcano, and you can even see the extent of the gas that's coming out here. Now, here's a question to see how well you are listening, or perhaps how well you heard that video earlier. How high, and you can put your answers in the chat window, was the ash plume from this volcano, and why would that be important to know? So, giving an idea of the height of this ash plume and why that would be important. So we'll give you a second to discuss that and look for some answers in the chat window. All right, so we're getting some answers coming in. I was just saying to Melissa, I wish I could be in your classrooms to see the discussions going on, but we're getting 20,000 feet is how high this ash plume is, which is absolutely correct. And Freelandheisen Middle School has also included that to be able to see how far the ash is going for travelers, or even to know how big the eruption is. Green Park Lutheran, excellent answer of keeping track of pollutants and the spread of the cloud and ash. Marburn Academy is also thinking about the pressure the volcano is producing, which perhaps can be associated with the extent of that volcanic plume. And Pine Lane also agrees with that 20,000 feet and to know how deadly that eruption is. An excellent point, Green Park Lutheran, and another school had mentioned this, travelers and air travel. If you've ever flown on a plane, planes fly sometimes between 20 to 30,000 feet around that type of altitude. And so you certainly, if you're flying in this area, would want to know to stay away from this ash plume because that could be very dangerous for the flight and the airline itself. So great answers and good listening to that video earlier. Well, let's just look at another volcano. This one happens to also be in the Aleutian Islands, that same area off the coast of Alaska. And this volcanic plume, again, looks a little different than the other two. But what's neat about this and what's so powerful from astronauts in space is one of our astronauts happened to be flying over this area on the ISS, noticed this volcano erupting, and actually called down to the Earth and said, hey, does anyone know the Cleveland volcano is erupting right now? And actually, they were not aware this volcano was erupting. This little spewing of ash and gas only lasted a short amount of time, but it was our astronaut in space that alerted the authorities on the ground that this was actually happening. So right place at the right time for this particular astronaut. Now, thinking about volcanoes and a very famous volcanic island chain, the Hawaiian Islands, which you can see here, is a volcanic island chain. And the Big Island seen here, perhaps it's named the Big Island because it is one of the biggest islands of Hawaii. Well, this Big Island is home of three main, maybe famous volcanoes. Perhaps if you live on the Big Island, they're kind of famous. So I want to know in the chat window if you can name any of these volcanoes on the Big Island. So let's see if you know any of these, which is a tough question. So we'll give you a few minutes to think about it. Name any volcanoes on the Big Island. All right, so we're getting some answers from Green Park Lutheran, mentioning Kona, which is one of the main cities on the island, and Mauna Loa. Freelandheisen Middle School is mentioning Kilauea, Mauna Loa, and Kona. And Kona is actually the name of a town, and an airport happens to be in Kona as well. And there's the tallest volcano on Earth, actually, and Pine Lane Elementary has got it, Mauna Kea. So Mauna Kea, Kilauea, Kona is a city, but let's take a look at some of these volcanoes from our astronauts' perspective. This is Mauna Kea, and Pine Lane Elementary mentioned this. This is actually the tallest volcano on Earth. It's hard to kind of tell the elevation that it's at in this picture, but it is so high, these little white dots you might be noticing in the center of this Mauna Kea, these are observatories. This is a great place to do sort of stargazing because you're so high up in the atmosphere, you don't have a whole lot of sort of extra atmosphere to look through. So this is a view of Mauna Kea, tallest volcano on Earth. Here's a view of Kilauea, and perhaps before Christmas time, you might remember hearing about Kilauea. This is one of the more active volcanoes on the island of Hawaii, and you can see that it's spewing some eruptive materials here, some gas, and the flows from this volcano were actually getting dangerously close to one of the towns nearby. So Kilauea is very active. And then here is Mauna Loa. Mauna Loa is a broad volcano, and I'm going to go back here for just 1 second. So you can see here's Mauna Kea, that tall, tall volcano. Here is Kilauea. You can even see in this global island view, it's spewing some gas. And here is Mauna Loa, meaning a long, broad, shield-like volcano. And this image that we had here is really showing a nice view of sort of that central caldera or central vent and some of the lava flows coming out. Now, what's neat about these pictures and volcanic imagery is you can actually even map the different flows. You can see different colors of flows, and actually some geologists actually map volcanic flows, whether it be on Earth or even other planetary worlds. Now, looking at this volcanic image, this is actually of Mount Etna in Italy. And again, if you were mapping this, mapping a volcano is as simple as kind of putting a little overlay on an image, and then you can color out or draw out, here's the dark volcanic flows, here's some older flows that are much more, they go a longer distance around this and they're different color, which allows you to know that different color and texture, it's a different volcanic flow. Now I'm going to ask you a question here based on this volcano. Now you can see some different lava flows and some different colors. So if I were to put an A for this lava flow and a B for this lava flow here, which lava flow is younger or the newest lava flow? Lava flow A or lava flow B, and how do you know? So let's get those geology thinking hats on. Which is younger or newer, A or B, and how do you know? So we've got Green Park Lutheran, A is younger because it's on top. Mauburn is thinking maybe B is younger because it's lighter. Pine Lane Elementary is thinking A is younger because it's closer to the volcano and has a different shade. So a little bit of some different answers here. But actually, Green Park Lutheran, you're actually, when you say A is younger because it's on top, you're actually using a geologic principle called the principle of superposition. A is younger because it is on top. You can almost see that it is on top of B. B is covered up by part of A. So A is definitely younger, and not just because it's closer to the volcano, but because that flow is on top of the other flows. And again, that's a geologic principle, the principle of superposition. All right, let's move from volcanic eruptions and hurricanes to something that moves a little slower, glaciers. Let's get your thoughts on what features do you think you might see in astronaut imagery of glaciers as we sort of change our focus here? And why do you think they might be important to study? So let's get your answers in the chat window and we'll see what you come up with. So perhaps glaciers aren't something you think about or are too familiar with. But in some cases, let's see, it'll be interesting to see what your thinking is and how that'll actually come to be in some of these images. So Green Park Lutheran is saying white cracked ice, frozen layer over long avalanches, perhaps glossy. Pine Lane is saying maybe some dirty snow or ice and water. Why they are important to study is related to global warming. Marburn Academy is saying you might see slabs of rocks. Freeland Hyson Middle School, white and blue ice as the glacier moves and can pick up the land below. And you can actually even see the path of the glacier, how it's traveling, and ocean level rising due to glacial melting is a very interesting thing related to this whole idea of global warming and the effects of glaciers. And perhaps Marburn is saying you can even see different colors of ice. Well, let's take a look. Now, this is the one image in this presentation which was not taken by an astronaut. This is actually a Landsat image, so it's an image taken from an Earth-orbiting satellite, but it gives us a great view of some terminology and this Columbia Glacier in Alaska. Now, you'll notice the end of a glacier is called a terminus. You can sometimes see some of the material breaking off the terminus and calving. We can call that when it breaks off, it's calving into this body of water. Moraines, some of you talked about rocks and debris being picked up by this moving glacier, and that is, you can oftentimes see in these darker sort of linear-like features, which are rock and material falling down slope or moving down slope with the glacier. Now notice where the terminus is here, and this image was taken in 1986. An image was taken over the same area in 2003, and look where the terminus is now. So this actually gives us one sort of data point of glaciers changing and how you can observe that in imagery from space. So let's look at an astronaut photo of glaciers to see what kinds of features can we see here. Well, here's the glacier itself, and again, you can see this dark material. This is a moraine or materials, rock and debris coming down slope with this glacier, and here's the terminus. And you can see some calving of ice kind of breaking off into this water area here. Now, here's another picture of that same glacier. This is the Uppsala Glacier in a Patagonia region, which is in South America. And if we look at these two images side by side, you can actually see from 2009 to 2013, look at the retreat of this glacier. Now, I know I have a question up here, but in essence of saving some time, I just want you to notice that this glacier, the terminus, has certainly pushed itself back or certainly has retreated. So this is something that you can see and actually detect and even measure using some useful tools, including Google Earth, where this glacier, if we look at imagery from space, has actually retreated about 3 kilometers, which is about 2 miles over this period of time. So as we look at this as just one glacier, the Uppsala Glacier, but here's some others. Here's the Viedma Glacier, and Melissa talked about this earlier. Again, in 2002, you could see the terminus of this glacier, and you can see in 2014 that has certainly shown some evidence of retreat, again, giving us another data point that glaciers are changing. Just to give you a sense of other glaciers that you can see, and you can see different colorations. This almost looks somewhat bluish, as well as some sort of dirty ice, as many of you brought up. And these sort of textural lines, these are actually crevasses. So they're almost like little canyons of ice, and they're actually, some of them can be quite tall. You can't tell that from this image, but this is just a view of a different shape of a glacier, even different colorations, and these are all from South America. Here's just another one, Tyndall Glacier. You can see this shape of this glacier, and looking at this image from 2007, I wonder if we looked at an image from 2014, if this terminus would have shown any signs of retreat. And just one other, because I thought it was a neat name and a really cool picture, Penguin Glacier, where you can see all of this calving. And as this ice is moving down slope and this ice is breaking off into these bodies of water, you're certainly going to have, in the end, some sea level rise, which is one very important aspect associated with global warming or even glaciers. So let's go back to Melissa and talk about something really cool, airplane contrails.
So first question for you guys, and I'm sure everybody's seen airplane contrails just standing on the ground and looking up at the sky. I'm wondering if you guys think that astronauts can see airplane contrails from space, and do you think they look similar or different than what we see from down here on the ground?
And you can see in that picture down below, there's some views of contrails taken from the ground looking up. So is that the same as the ground looking down or from space looking down? We'll see what you have to say. All right, so Marburn is saying, yes, they can see them, but they're different. All right, so we'll see Green Park Lutheran thinks, yeah, you can see them, and they might look smaller since you're so much higher up. That's an interesting thought and perspective. We'll see if anyone else has anything. Oh, Freeland-Heisen Middle School. They think maybe they can see them sometimes, and if they're lower to the ground, maybe they cannot. And another Freeland-Heisen Middle School group is saying, yeah, they can see them, but they probably look a little different. So remember this view. This is from the ground, and let's just show them from space.
They can actually see them from space, and everybody said, yes, you can see them. And they actually look very similar to what we can see on the ground, surprisingly enough. Now, they might look a little smaller, so if we compare maybe this image taken from space to the one on the ground, they do look a little bit smaller, but the idea behind them, the shape and how they follow the airplane itself, that looks very similar from space. And the way that these contrails form is the water vapor from the engines or engine or whatever kind of plane we're talking about interact with the atmosphere, and so they play with both the temperature and the humidity of the atmosphere, and they can form these long trails behind the plane itself. And depending on the atmospheric makeup, it might stay around for a couple of minutes, or it could be even longer. So I think we've all seen those pictures of contrails where they look kind of bubbly, and those mean maybe they've been around for a little bit longer, but if they're in these straight lines, maybe they're very fresh contrails. I wanted to add this image because I thought it was a really neat image. This is a contrail following the airplane here, a very crisp, nice, detailed contrail. But if you look very carefully, you can actually see the airplane against the blue water, which I thought was a very neat picture. The astronauts really enjoy taking pictures of airplanes and contrails from space because they do a lot of flying on their own when they're back here on the ground. So they really enjoy kind of connecting those two through imagery. Now, there's something going on a little differently here in this image of an airplane contrail, and I'm wondering if anybody knows what's going on. Do you see anything different? What do you think is happening to make this kind of contrail?
So we'll give you a few minutes to discuss, and we'll see what kind of answers you can provide to us. All right, so we're getting from Green Park Lutheran School, maybe there's some aerobatics and the Thunderbird planes are flying around doing some of these contrails. Pine Lane is mentioning there could be multiple planes creating air patterns, maybe even an air show from an Air Force base. Green Park Lutheran is also talking a little bit about the wind picking up. Freeland-Heisen is mentioning a different type of plane. Perhaps it was in need of some type of emergency landing or so. And they've also mentioned that the airplane is circling. And Marburn is mentioning about the humidity in the engine is allowing us to see that pattern. And Freeland-Heisen is mentioning maybe doing a search pattern or potentially even an emergency landing. So very, very interesting answers coming in. Melissa, what was your thought on this one?
Yeah, those are actually very great answers. What is actually happening in this image here, this is a holding pattern. And so I think somebody actually said the airplane is circling, which is completely correct. Now what happens in a holding pattern is the airplane needs to be delayed while keeping it near an airport or in a particular airspace. So what's happening here is just imagine that you're flying home, you're over your home airport, and you're wanting to land, but there's actually an airplane that's about to land right before you. So you need to delay your aircraft without leaving the general area of your airport. So you'll do a circle around the airport itself right before you get to land. And that's what this airplane is doing here. This is in southern Ontario in Canada. So the airplane is coming in this way, and then they come around and do a long oval pattern here. And they finally do one circular holding pattern that you can see this perfect circle here. And this is the airplane actually leaving the holding pattern. Now this is kind of like just being in the right place in the right time for the crew on the International Space Station being able to take this image, but it was a really neat picture.
That is very cool. So with that, we've talked about glaciers, we've talked about contrails, we've talked about volcanoes, we've talked about hurricanes, and we've been talking about astronauts taking these pictures from space. So here's a question for you guys out there. If you had the opportunity for an astronaut to pick up a camera to take images of the Earth for your class, would you be interested in having that occur, yes or no? And what topic interests you? If you were going to have them take a picture of something, what would you be interested in them taking a picture of? What would you want to study or investigate? So we have from Green Park, yes, we would be interested in having astronauts take a picture for us. I know I would be interested in having astronauts take a picture for me. Melissa tells them what pictures to take on a daily basis for scientific and school purposes. So Green Park Lutheran would be interested in volcanoes and rivers, and you can certainly tie it into things that you're studying in class. Perhaps other groups are still talking, so I'm going to, see other answers coming in. Friedenheisen is talking about, yeah, they'd be interested in looking at, yes, getting imagery, but also be interested in snowfall, tornadoes, tsunamis. Even Green Park is mentioning hurricanes and looking at the streets afterwards. I will say it is difficult to get imagery of tornadoes because they come about and they go away generally quite quickly. But hurricanes you can certainly see. Volcano erupting at night, I don't know if I've ever seen anything like that, but that would be certainly interesting. Crop progression, which is very interesting from Green Park. Changes in vegetation, and that whole idea of change over time would be very interesting. And even Pine Lane Elementary is talking about ocean trash, glaciers, tsunami, canyons, landforms, tornadoes, deserts, flash floods, rainforest, deforestation. Wow. And some of those things you can see in images, some of those things you cannot. So as you think about in your class, if you would be interested in having astronauts take a picture for your class, you have to think, okay, well, how do we make this happen? Well, first of all, we have a program called Expedition Earth and Beyond that allows student groups to put in requests for astronaut imagery. But you can't just say, I want a picture of a volcano. You kind of have to have a scientific thought and investigation associated with it. So, for example, you choose a topic of interest, and many of you name topics. Think about, is your topic of interest something you can see in a picture? And that's very important. But once you have a topic, then you have to formulate a question that you can investigate and answer using imagery from space. You thirdly have to plan, how are you going to answer your question with this imagery? And then fourthly, you can put that all together and work with your teacher to put in a data request. So this is kind of tough, and I'm going to ask maybe just one question here. Out of the 3 questions that I have listed, which do you think would be most suitable to ask and answer using astronaut imagery from space? So think about A, how do volcanoes form? B, why do volcanoes erupt? Or C, if you were to map the lava flows on 30 volcanoes imaged by astronauts along the Ring of Fire, what's the average number of lava flows per volcano? So which is the most suitable question to ask and why? So we've got a couple of answers of C being the most suitable question to ask. What makes it the best kind of question to ask and answer using astronaut imagery? Which is a tough question in itself for you to be able to sort of answer, but we'll see if you can come up with why is C the best investigation question to ask. So everyone is in agreement that it is C. And I'll give you a few minutes before I share my thoughts on that, just to give you a chance to talk amongst yourselves. And we actually have some great answers. Now, Green Park Lutheran School saying it shows how active the volcanoes are or have been. Friedenheisen Middle School has kind of hit the nail on the head because A and B cannot be seen in photos. That in itself, and there are certainly other reasons that go along with why A and B might not be as good a question to ask, but the idea of what you can see in a photo is perfect. And Pine Lane Elementary also mentions it. You can't look up the answer to question C. You can look up, you can do an internet search of how do volcanoes form. You could do an internet search and you've got your answer in about 2 seconds, or maybe 3, depending on the speed of your computer. Why do volcanoes erupt? You can ask that question on the internet and find an answer right away. But C, you have to look at imagery, you have to do your mapping, and then you would come up with an answer by working with and making observations of astronaut photos. So that is excellent input from you guys out there. C would be the best question to investigate, and you have all given great answers as to why. So as we move to just a couple of things, where can you find more images? Well, we have a great website, our Gateway to Astronaut Photography of Earth website, where we have collections. So you can see images of different glaciers on Earth, or different volcanoes on Earth, or different impact craters and more. So our Glaciers collections is a great, or our collection page is a great page to look at. But you could also search on our Search Photos tab. You can put in, I'm looking for Etna volcano or Mauna Loa. You can put in features or specific areas and you can search that way, because you have to show that you're looking at images and using images as part of your investigation. Now, just for especially you teachers out there, what kind of information would you need to put in to a data request? Well, you tell us a little bit about your team. Who are you? Where are you? What grade are you in? That kind of thing. A little bit about your project information. What's your topic? What's your question? How are you going to go about answering that question? And what images have you already looked at? And then you get to tell us exactly what you would like to have imaged from space. Pretty easy, pretty cool to get your own image of the Earth taken by an astronaut on your behalf. And this is just a sample of one group's image that was studying Viedma Glacier. So we hope you think about doing some investigations, and we hope that some of the things that we have chatted with you today, that they have sparked some interest for you to maybe do your own investigation. So with that, we want to thank you for joining us, but we're not done yet. We actually want to be able to get questions from you guys if you have questions. So what we're going to do here, so unfortunately you won't be able to, rather we won't be able to see you, but you're going to be able to see us here in just a moment. As you have questions, and we have at least 10 minutes or so before the top of the hour, so as you have questions, you can type those questions in, and Melissa and I are going to try our best to answer them. So I'm going to look at my other computer screen to see if I see questions coming in, and then I'll pop back in if I'm going to answer any. But we'll leave it over to Melissa, and let's see what kind of questions we have coming in. Here's one from Freeland Heights Middle School. How long does it take for images to reach us from the ISS? So maybe, Melissa, you can, for any picture to come down to Earth, and also a picture a student group might ask for.
Sure. Well, the first question that Paige was just asking is how long in general does it take the images to come down from ISS down to us? It usually just takes a few days, depending, it all depends on when the astronaut takes the images out of the camera, sticks them into a folder that can then come down to us from the space station down to Earth. So that usually takes just a few days. And it really depends. Now, the second question about when a student group might get their imagery, that depends just where the ISS is flying, how the weather conditions are going that day when we ask them to take the image. And so sometimes it could take just a couple of days. Sometimes it could take a couple of months. It really depends on where the ISS is flying and what time of day they're flying over that area, so we can get you a good picture that your classroom can use.
And I'll just add to that, one of the things that Melissa does on a daily basis is she looks at the orbit tracks of where the ISS is going to be on a given day, and she also looks at the weather, what the weather will be like on a given day, and she literally writes messages to the astronauts to say, such and such a class is asking for this picture. Hopefully you can get to the window with this camera to be able to take a picture if the weather's good and the cloud coverage is suitable. Because she knows how busy the astronauts are, and she's very good about making sure that she's not asking them to go to the window to take a bunch of pictures of clouds if someone is interested in seeing a volcano. So it is certainly something that could have, like she said, a month or more sometimes, depending on the image you're looking for. Now let me ask you this, Melissa. Is it, if you wanted an image, if you take or asking for an image around the equator, does that give you maybe a quicker time frame for return of the image versus if you're looking at a picture at a higher latitude north or south of the equator?
That's a good question. It does help you if you're closer to the equator than being very high latitude or very low latitude. So the equator, you know, near Mexico area on our side of the world, or Africa, northern Africa on the other side of the world, that kind of area you get more sunshine whenever the ISS is passing over, so you have more likelihood of us being able to get your image quicker if they're in that area. Now, if you're very high, like we're maybe northern Canada, we're probably not going to get your image because the ISS doesn't even fly that high, but also they don't have very much daylight up there either when the ISS is flying over. So it really also depends, like Paige mentioned, where your target is over the area.
Excellent. And the ISS does travel from 52 degrees north to 52 degrees south. So that's its orbit track. It doesn't ever pass directly over like Antarctica or the Arctic. So 52 north and south. Now, Green Park Lutheran School is asking, what kind of cameras do the astronauts use?
Cool. Good question. Well, right now they're using a Nikon camera, and it's actually something that you can go buy right now if you had a couple of $1,000s, I guess. But they're very nice cameras that are actually just off-the-shelf cameras. They're the D4 camera, Nikon. But in addition to that, they've also got maybe a couple of video cameras up there. Now, we don't ever ask them to take imagery with those because they don't have very good resolution. And they also have...
NASA is taking the space station.
Sorry. They also have other cameras up there that we also don't ask them to use imagery. They have some IMAX cameras up there right now and some other very neat cameras up there.
Awesome. Sorry about that little loud interruption there. It was like the astronauts talking to you from space, which brings up our next question from Freeland-Heisen Middle School. They're asking, what do you use to communicate with the astronauts?
That is a good question. Right now, what our group uses is we actually construct a message, kind of like if I were to send you some kind of message, if it was maybe in a Word document on a computer, I do the same thing for the astronauts on the space station. So I'll construct a message for them in just a Word document, and it gets shipped right up to them, and they get to read it exactly how I printed it out for them. And so that's when Paige said before that we can mention your school's name to the astronauts. So I would put it right there in that message to them.
And what's interesting is for groups that do put in requests, anytime Melissa or the other members of the group send the astronauts a message to go to the window to try to take your picture, we give you a little snapshot of the message that was sent up to the astronauts so that you know, oh, tomorrow at such and such a time, the astronauts, if they can fit it into their schedule, might go to the window to take a picture for us. So the astronauts are really busy, so they're not always able to take a picture when, like Melissa tells them to, if they have other things going on or other tasks to tend to. But now, Melissa, aside from these messages, do you ever talk with them on the phone or via email and things like that?
We actually do. We get to talk to them on the phone. If my manager was here, she'd actually be able to tell you that one day we were in her office talking about something, and one of the astronauts decided to call her on her office phone, just a regular little office phone, and I can't remember what the caller ID said. It was something like unknown, which I guess makes sense when they're flying 220 miles above us. Might be an unknown location, but we get to talk to them on the phone sometimes if they need to ask us questions, or they will communicate through other channels to talk to us, but we do get to email back and forth sometimes or talk on the phone, whatever they need, if they need us to answer questions for them.
Yeah, so talk about a long-distance phone call. One from space is pretty cool.
Yes.
Okay, so let's see. We had another question that came from, let's see, I think it was Marburn Academy. I'm looking back in my log here. Yeah, Marburn Academy was wondering, does the area of a volcano impact the atmosphere? And that's a really good question, Marburn Academy, because if you think about the volcanoes, if they are erupting, depending on, is it an explosive eruption? So sometimes like stratovolcanoes or a certain type of volcano that has a very explosive eruption, how much that material gets sort of erupted into the atmosphere is certainly going to impact the atmosphere, not just in terms of travel, but also dust particles or gas particles or ash particles that eventually will fall out of the air and into, well, through the atmosphere, into the ocean, covering areas and towns. I've seen pictures of huge volcanic eruptions where ash has literally fallen kind of like snow and covered houses and areas, just that ash coming out of the atmosphere and falling out onto the terrain. So certainly the area and the eruption itself is going to have an impact on the atmosphere and all the materials that are getting erupted into the air, which will then later fall down on the ground somewhere, somehow. So it is a sort of a cycle and a process and definitely has quite a bit of impact. So good question. Let's see what other questions I can come up with here that you guys are answering or asking. Here's again from Marburn Academy, and you kind of touched on this before, but they're asking, you know, there's sometimes a time delay. When we communicate with like spacecraft at Mars, sometimes there's a 10-minute delay in getting an information or communications back. So they're kind of wondering how many light seconds does it take for a picture to get down to Earth. So is there a real delay once they do put the camera stick into the folder and you guys getting it? Is there a couple of minute delay in communications like that?
That really depends on both where they are over the world and if they actually have communication with the ground at that point. Sometimes they'll go through what's known as AOS or LOS, acquisition of signal or loss of signal. If they're going through an LOS, we actually don't have communication with their, whatever, if it's a computer that's going to be sending down the imagery, we actually don't have communication with it at that point. So there might be a delay, but if they are at the right spot, maybe kind of nearby where we are, and they have acquisition of signal, then we can actually get that pretty quickly. It's kind of just like copying, pasting from your desktop to somewhere else. That's kind of what they're doing from up there.
And are there certain antenna that are used that allow them to be able to communicate with the Earth? Like, what if they're over Australia? Are they communicating direct to Earth through the use of some kind of antenna or something?
Well, I know that there are several communication bands. I know there's something known as the KU band that they have communication back and forth from the ISS, but I'm not sure exactly specific satellites if they use those to bounce the signal if they're over different parts of the world. I'm not sure about that one.
Okay, awesome. All right, so Freeland-Heisen Middle School is wondering, so what happens if they're using a camera, they want to have a camera being used, but it breaks? How do they fix it, or how do they get the parts that they need? How does that work?
Well, depending on what happened to the camera and what needs to be fixed, they have certain tools up there that they can use to fix the camera. But if something's so far gone beyond repair, then they might have to ship another one up, which means they need to wait until the next vehicle goes up to the International Space Station. I know that there is a 3D printer up there that they are looking into being able to send up tools or spare parts for certain things to the crew. I'm not sure if we've already done that or not yet, but it's something that we're looking forward to in the future.
Awesome. So Marburn Academy is wondering how many astronauts are on the ISS?
At this very moment, we've got 6 astronauts up there. We've got, I think, 2 NASA astronauts. One from ESA, which is the European Space Agency. She's from Italy. And then we've got a few Russian cosmonauts up there as well. Starting next month, we'll have a very historical mission coming up where our NASA astronaut and 1 cosmonaut from Russia will be spending 1 year in space. Typically, and I think somebody else asked this, typically our astronauts stay up there for about 6 months, and so they'll come back down and they'll finish their science objectives after that 6-month period. But these new astronauts that are going up starting next month will be up there for 1 year, so double what typically we go up there for right now. So that's a pretty interesting and exciting time, I think, for all of us.
Yeah, and that actually does answer a question from Freeland-Heisen Middle School that was asking how long they're in space. So why are they oftentimes not in space for a year or longer? Why is that?
That's a great question. This is all one giant science experiment. So what's happening is once the astronauts come down, we do see that there is certain pieces of their anatomy have changed. So for instance, their eyesight might change a little bit after spending so long up there, or their bone density could change just from having no gravity, going from gravity down here on the Earth to no gravity up in space. Things change in your body. So right now, the longest we've gone is the 6 months, and we have been noticing some changes in bodies. Now that we're going to be going up there for a year, this is all in preparation for getting further out into our solar system, like to Mars and beyond. We're going to see just what it takes, what tolls it takes on the human body for being up there for an entire year.
Excellent. And that, and thinking about it, Melissa, can you mention at all, the astronauts can't always be at the window taking a picture. What other tasks are they doing, either to monitor their own health or are they doing other science experiments? Are they busy all day long?
That's a great question. The reason that sometimes, even if we do ask the crew to go to the window and take a picture for us, that they can't, is because they are so busy. Their schedules are jam-packed, full of different science experiments or human anatomy experiments. Like I was mentioning, the eyes change over time, and they do ultrasounds on each other. They take blood from each other. They do science experiments by growing plants up there. They do, they have to exercise at least maybe like 30 minutes to an hour every day, possibly more, just to keep their bodies sort of like they are down here on the Earth. But they've got many more science experiments that are going on up there, not including when they have to actually leave outside of the ISS to go do something known as an EVA. And what they'll do is they'll put on all their spacesuit gear and they'll go out into space and work on the outside of the spacecraft. Sometimes those would take up 1 or 2 days just in and of itself. So they have a lot of things going on all at once up there.
Yeah, they are very, very busy. And speaking of time, not that we're going away just yet, but I just noticed that we are 7 minutes past the top of the hour. So for those of you that might have to depart and go to your next class or go back to class, whatever the case may be, if you aren't able to stick around with us for a little while longer, we really want to let you know how much we appreciate you guys joining us today. For those of you that can stay on the line, we'll stay on for a little while longer answering some questions so that we can try to get you thinking and see what you're thinking and then answer additional questions you might have. So again, if you do have to depart, thank you so much for joining us today. For those of you that are going to stick around, we'll get more questions.
Yeah.
So I do have another question that I saw, two that I saw come in. One related to this communications thing. Do the astronauts have some kind of phone? I mean, do they use a cell phone? Do they use a satellite phone? What kind of phone do they use to communicate when they call down to Earth? Do you know?
Well, I know that they have, they might have a satellite phone up there. I'm not sure exactly the kind of phone that they use to make calls down to Earth. I do know that they have video conferencing up there, maybe via Skype, but this is just so that they can see their family and talk to their family on a daily basis, because being away from your family for that long is, of course, very hard. So they'll get to have video conferences with their family or video conferences with NASA or whoever they need to. So they have different means of communication, not just a regular phone that I pick up and give you a call, but also getting to see human faces down on the Earth as well. So they have a lot of different options.
And you figure if you're away from your family for so long and living in somewhat small living quarters, it's probably nice to kind of take everything else away and just see your family right in front of you.
Yeah.
Here's a question from Freeland-Heisen Middle School. They're wondering, how long does it take the ISS to orbit the Earth?
Oh, that is a good question. So it takes them approximately 90 minutes, so an hour and a half, to orbit the Earth. So over the course of the day, they actually see about 16 sunrises and sunsets, which, opposed to our one of each, is pretty neat. So they get a lot of great imagery of the sun rising and sun setting. But this also allows them to be able to photograph nighttime and daytime interchangeably very quickly. So instead of only spending 3 hours in a block of time of nighttime, they actually get to see the Earth the daytime and nighttime cycle. So it's about an hour and a half between the two.
So does that make it difficult for them to sleep if the sun's coming up every hour and a half? Do you have any thoughts on that?
Well, they have, and this sounds very bad, but they actually have little closets that they sleep in with no windows to the outside, just so they can have complete darkness if they really want it. And if you think about it, you don't need to lay down in space, so they have a little sleeping bag that just comes right over them, and they sleep just like that. So they don't have windows or anything to the outside, so they can actually close themselves off and kind of be alone if they need to.
So they kind of like strapped or Velcroed to the wall or something?
Yes, they are. So they don't go floating around everywhere. They are strapped to the wall, so they can just kind of sleep in their sleeping bag with a hint of gravity, if you will, because they're being strapped to the wall.
Very interesting.
Yeah.
Now, Freeland-Heisen Middle School is also wondering, so what is the daily life of an astronaut despite all the work they are doing while they're in space?
The daily life of an astronaut. Well, it's very similar, I think, to how we work down here on the ground. For instance, Paige and I come into the office, we get work done on the computer, or maybe we go to a lab and do science experiments. Whatever we do here, it's very similar to what they do there. So they'll have their typical work day when they spend 8, 9, 10 hours working, and then they actually get time to themselves and time to call their house and their family, or they can actually bring movies up with them and they can watch movies if they need to on their spare time, something to keep them sane, if you will, because you don't want to keep them working all the time, of course. So it's very similar to an office atmosphere.
So sort of related to that, can they like wake up whenever they want to and sort of then kind of decide when they're going to do certain tasks, or is their schedule very regimented?
Would that be great if you could just wake up and start working whenever you want?
Yes, that would be great.
They definitely have a specific time that they are called to say, wake up, it's time to get up. They have maybe 30 minutes to an hour to get themselves up and ready, to go brush their teeth, eat their breakfast, talk a little bit to their friends, and then it's straight to work. They'll have a conference with the ground, they'll do whatever they need to do for the science experiments, and then that's their day.
So pretty much someone telling you what you need to do.
And when you need to do it.
And when you need to do it. Okay, well, you students out there, when your teacher's telling you what you need to do and when you need to do it, that's kind of exactly what happens with the astronauts in space. I was also going to ask, sort of related to that, and I see the question coming up from Freeland Heisen. I think we might have some potential astronauts in the future there as they're gathering all this information and asking such great questions. So they want to know, one, what do the astronauts eat in space?
Oh, so we actually have a food lab here at Johnson Space Center where several different team members make these meals for the astronauts. So they'll actually sit down, talk to the astronaut face-to-face before they go fly and just say, hey, what do you want to eat while you're up there? And they'll put a balanced meal together for them, but the thing is, they have to package it in a certain way that when the astronauts get up there, they have to prepare it either by hydrating it with some water, or they have a little oven type of thing where they can heat it up. But it doesn't look the same as we eat stuff down here. I don't know if anybody's ever tried the astronaut ice cream. It's the freeze-dried little cubes of ice cream, and it's kind of something similar to that, but they can actually hydrate it when they go up there.
Have you ever had it?
Astronaut ice cream, yes. I went to space camp and had astronaut ice cream. And
was it good?
It was pretty good, yeah. I mean, compared to regular ice cream, probably not as good, but it was pretty good.
Excellent. So they're also wondering, so if an astronaut gets sick, what happens? Do they send them back to Earth, or how do they deal with that?
Yeah, that is a good question, because you want to be very careful with your immune system while you're up in space, of course. So they take extra precautions when they're down here on the ground right before they fly. So they go through something known as a quarantine period right before they go up, where they are not allowed contact with anyone except for some of their select team members and their actual crewmates that are going to be flying up with them. So they are kind of shut off from the world for a couple of weeks before they even fly to make sure they're not sick, that nothing's going on with their bodies or anything, so that they can go up there healthy when they get up there. But while they're up there, they also have a team of flight surgeons down on the ground that they can call anytime and say, hey, I'm feeling this way. What do you recommend? And they've got stuff up there to help them kind of pass stuff if they need to. But they have doctors here on the ground that actually get to talk to them on a daily basis to make sure they're healthy.
Awesome. Well, I don't see any other questions. I don't think. Hopefully I didn't miss any of the questions that came in. So we are at about 15 minutes past the top of the hour, and so we're probably going to get ourselves back to work, or maybe even get some lunch, because it is about that lunchtime, depending on where you guys are. But first of all, we want to mention that we are so thrilled to have connected with all of you. Your questions were great. Your answers were great, and I really want to thank Melissa for her time and expertise. As you can tell, she's a wealth of information, and as she works with the crew and trains the crew and then gets to communicate with the crew, being able to share that with all of you in the classrooms across the nation it's really a great opportunity. So thank you for Melissa for joining us today. And I guess with that, any closing remarks from you, Melissa?
You know, the reason that I'm here where I am today is by studying some of the stuff that you guys are studying right now, education and technology and math and science. Those are the key things that you guys studied to get to where we are today, and I think that it was well worth those few years of studies to actually get to talk to the astronauts and communicate with other cool scientists. It's a dream come true, and if you have this kind of dream yourself, then I think that you should follow those areas.
Yeah, so stay in school, work hard, and I don't think either one of us, I know I never thought I'd ever be working at a NASA site like this, and it's great to love what you do, and I think you can tell just by hearing Melissa talk that she loves what she does, and so it's so great to be able to share that with you. So great advice and thoughts. And to all of you guys out there, stay warm, stay safe in those treacherous cold conditions, and we look forward to connecting with you sometime again in the near future.
Yeah. See you soon.
Thanks, everybody.